So this lesson deals with graphing, phase shifts, and vertical translation. So what helps some students is to make a list of the steps and the order in which you should think about these things. Okay, so the first thing you need to consider when graphing trigonometric functions is, can you find the period? Okay, and then can you find the section? So you might have to divide by 2 or by 4. Okay, and then you label the x-axis. So you figure out everything you need to know for the x-axis. Okay, the second step is any shifting up or down. So you have to look at the vertical translation and figure out where is the new middle. Okay, after that, then you use the amplitude. So after you find the middle, then you find how high and how low from there the graph will reach. Okay, and that is the amplitude from the middle. So this is the order in which you should do things. First you get the x-axis, then you get the y-axis by the shift, and then the amplitude. Okay, the fourth thing you're going to do is figure out the phase shift. So do you have to go left? Do you have to go right? Where am I going to be starting? Okay, and then the last step is you ask yourself, how does the graph start? So if it's a sine curve, it starts in the middle. Cosine starts either high or low. Tangent on the y-axis starts with that's right, a point. And cotangent starts with an asymptote. Okay, let's do that. We're going to do all these steps. And of course, when you're graphing, you have to ask yourself, is this equation ready? And the answer for this one is no, it is not ready. So I'm going to go ahead and factor out that 2. Maybe I will use some big brackets here. 2 is going to get factored out of the x plus pi. It's still inside of the sine function, so that is the b. We've got an a b, a c, and a d number. This is a sine curve. So the period for sine is 2 pi over b. So the period is just pi. A section for this kind of graph, sine divides by 4, that's pi over 4. Amplitude is the absolute value. That is going to be a 5. Okay, so how do I graph? The first step up here says find the period in the section and label your x-axis. Okay, let's do that. Let's label the x-axis. 1 out of 4, 2 out of 4, 3 out of 4, and 4 out of 4. Good for a period of pi. Let's go ahead and copy this to the left. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. All right, let's consider the shift up or down. Step 2 is the shift up or down, and this does have a vertical translation of up 3. 1, 2, and 3. So that is the middle. Okay, and what does step 3 say to do? Consider the amplitude. So the amplitude here is 5. So this graph can reach from 3 up 5 more all the way to 8. Or it could reach 5 units down, 1, 2, 3, 4, 5, all the way to a value of negative 2. I'm going to go ahead and put some dotted lines here for my high, my middle, and my low. Okay, the next thing to consider is the phase shift. This graph starts a phase shift of pi to the left. Wow, way over here. Okay, so somewhere way over here, I'm going to start drawing my sine graph. Where does a negative 5 sine start? High, middle, or low? Well, yeah, he would start in the middle, but he's going to start by going down. Okay, now I have to remind you guys that a graph like this, all of your points either go on the high, the middle, or the low. The x-axis is not a place to put a point. Okay, so the next special section is negative 3 pi over 4. That's going to be down here at a minimum. The next special section, he's going to be at a middle. Negative pi over 4, he's at a high, y-axis a middle. And then he's going to be at a low, then a middle, then a high, then a middle. Okay, please do not be tempted to put any points on the x-axis. That's going to be weird. I know he has an x-intercept, but that's not a nice one. So I hope that no one asks me to state them. Okay, sine graph. A minimum, a 0, a maximum, a 0. Not really a 0, but it's the middle. Okay, domain for sine is all reals. The range goes from brackets -2 up to 8, and no asymptotes. Okay, so you have to get used to this order of doing things. First, you take a look at the period, the section, the x-axis. Then you shift up, down, draw your middle line. Then you do amplitude up and down to make your high and your low line. Then you figure out where am I going to start, left or right, and how does that graph specifically start. All right, let's practice again. We've got a cosine curve here. Is this equation ready? No, it is not ready. So let's go ahead and factor a 2 out. So we're going to take a 2, factor it out. That's dividing by 2. Divide by 2. And then you have to divide him by 2. So that's going to be pi over 2. Did that work out correctly? Let's see. If I distribute 2 times x, yes. 2 times pi over 2, that would cancel perfect. Okay. The period for a cosine graph is 2 pi over 2, so the period would be pi, and a section for him would be pi over 4. Okay, let's go ahead and graph the x-axis. I notice here that I have to shift down 4, so I want to leave some space down. Maybe I'll put my graph a little bit higher. We've got 1 out of 4. 2 out of 4, 3 out of 4, and 4 out of 4. Go ahead and copy it here on the left. Okay, after you get your x-axis all labeled, it's time to take care of the y-axis. So the first thing we want to do is any vertical translation. We have to shift down 4. 1, 2, 3, 4. That is the middle. Okay, after you figure out the middle, it's time to do amplitude, which is 5. So if you're down here at -4, and you could reach up 5 units, 1, 2, 3, 4, 5. That's as high as +1. And go back to -4, because from here you could reach down 5 units, taking us to 1, 2, 3, 4, 5, -9. So your entire graph is going to be between -9 and +1. Okay. The next thing you do is you consider the phase shift. We have to shift pi over 2 to the right. Pi over 2 to the right, it's way over here. Should I put a point on high, middle, or low for a positive cosine? The answer is at a high. Okay, all of your points on dotted lines. The next special section would be a middle, and then a low. Going this way would be a middle. You could say a minimum, a middle, a maximum, a middle, a minimum. That's just a lot of M words. There we go. This is our cosine curve. Once again, I notice there are x-intercepts, but those are in the middle of sections, so don't ask me for them, please. Not until next chapter. The range is going to be brackets, -9 up to 1. And of course, there's no asymptotes. Oh, how about a domain for a cosine curve? It's all reals. They never stop. They're continuous. Okay, the last one that we're going to graph here is the shifting of a tangent graph. So let's go ahead and take a look at any, let's see, there's no up, down. The b value here is 1. So the period for him would be pi. And a section for a tangent graph would be pi over 2. Okay. All right, let's go ahead and do this. So we're going to have sections of 1 over 2, 2 over 2. Done. Of course, you can do more than just this, but this is 2 complete periods. Okay. After you get your x-axis, is there any up, down shifting? No. Okay. They don't have any amplitudes. In fact, there's no vertical stretch shrink. So the next thing I'm going to do is consider the shifting. I know that a tangent graph usually starts off on the y-axis like this with a point. But I'm going to have to shift that point pi over 2 to the right. Okay, so let's go over here to pi over 2. That is where I'm going to start with my point. And every other thing is going to get an asymptote. Now, since there's a negative, I'm going to have to reflect this over the x-axis. So instead of going up, up, up to the right, it's going to go down, down, down to the right. Start on the left, down, down, down to the right. Oops, make it bigger. Okay, domain is all reals except there is not any graph where 0 plus or minus pi n. The range for this one is all reals. Are there asymptotes? Of course, x equals 0 plus or minus pi n. Are there zeros? You betcha. X equals pi over 2 plus or minus pi n. Okay, so that's some review of shifting when you have periods that are not 2 pi and when you've got lots of steps. The next thing that I want to look at here is how to write the equation of a graph. So here's some graphs, and the problem tells you if it's a sine, a cosine, a cosecant, a secant, or whatever it is. So I know that this could either be a sine or a cosine, but they want me to write a sine equation. So there's a couple of things that we need to do for this. Okay, first of all, let's figure out what the period is. The period, let's see. If I go down, up, down, there's one complete cycle, and it looks like the period is 2 pi. Period is 2 pi. Okay. How about the amplitude? The amplitude of this graph. How high and low does it reach? 1. Okay. And then the other thing we need to figure out is the phase shift. Okay. Any phase shift. A sine graph usually starts in the middle. Okay, and I noticed that this one is starting in the middle. But perhaps it was starting over here. Or perhaps it was starting here. Or goodness, perhaps it's starting here. There's lots and lots of ways to do this. So I'm going to say, let's have it start right here. And I won't have any phase shift. But I am going to have a reflection. Okay, let's see. Don't forget y equals. The a value is 1, and then this is a sine curve. Since the period's 2 pi, the b is 1. So I'm just going to have x. There's no shifting, but it is going down. So I am going to have a negative out in front. That would be if I started right there. Well, some people say, well, how about if we start over here? Let's shift pi to the left, and let's write our equation there, but for a positive sign. Okay, what if I was to do that instead? So I would still have an amplitude of 1. The period is still 2 pi, but now I'm starting to the left. So that would be parentheses x plus pi. And I wouldn't need any reflecting if it started right there. Wow, it looks to me like there are infinitely many answers for these kinds of things. I'll probably write down the top 2 or 3 that people would do most frequently, and then you could always ask me if you have another original one. All right, let's practice cosine. I'm noticing here the cosine curve, starts at a maximum, and it is. So this is just a regular cosine graph. But I do need to make sure that I consider the period. Down, down, up, up, the period is 2 pi. Okay, the amplitude is still 1. Okay, let's start right here. Let's start at the regular place. So y equals 1 for the amplitude. This is a cosine graph. There's no shifting, so just cosine of x. Oh, that was great. Well, some people say, well, can't you start it over here? What if it got shifted here and that was the starting point? Ooh, let's try that one. So the amplitude is still 1. The period is still 2 pi, but I need to shift it over to the right. This would be to the right, so I need to say x minus 2 pi. There's a very common answer right there. You could also start down here. Let's try to figure out this answer. So we still have 1, we still have cosine. Oh my goodness, if it's starting over here, I need to shift it to the right and reflect it. So let's put a negative out in front. And then shifting it to the right would be x minus pi. There's another good answer. Lots and lots of answers. You don't have to have all of them, but it's good practice in the beginning so you get good at it. Okay, let's try tangent curve. A couple things to think about tangent. Let's see if we can figure out the period of this thing. Maybe some asymptotes would help here. Here's an asymptote, here's an asymptote. So it looks like pi over 2 left, pi over 2 right. That looks like a period of pi. Is that a regular period? Yes, that's a regular period for pi. Okay, so let's get started. Y equals, I can't tell if there's any stretching, so I don't think I'm going to ask you guys to do stretching for tangent because you just have to make up a number. So this is just a regular one. Tangent. Let's see. Do tangents usually start in the middle like this? I think they do. But they usually go up to the right. So I'm going to need to do a negative tangent of x. Well, some people say, well, what if we start over here? Could this be another place to start? It still needs to be a negative tangent. So it still needs to be a negative tangent. But if I shift over here to the right, that would be parentheses x minus pi. Okay, I know there's ways to say cotangent, but this one wanted me to say tangent answers. Okay, here's a cotangent example. A cotangent example that looks like it got shifted up. Okay, we got to shift up there. How about the period of this thing? Is the period still pi? Yep, the period is still pi, so that's a regular period. This definitely went up 1 unit. So let's see. If I were to think about a cotangent graph, he usually starts with an asymptote. So I need to look right here. Here's the starting asymptote. It got shifted over. Let's see. A cotangent graph usually has asymptote, and then it usually goes like this. So the asymptote got shifted to the right. It does not have any reflections, so let's start with y equals a positive cotangent. It got shifted to the right, pi over 2, so let's say x minus pi over 2. And is that everything? Oh, we forgot about the up 1, so let's put plus 1. Okay. Oh, I could say that the cotangent got shifted to the left. Maybe this asymptote got shifted over there. So it would be y equals still a regular cotangent, no reflection. The b value is still 1, except now it got shifted to the left, so that's plus pi over 2. Is that everything? Oh, don't forget about the plus 1. Okay. We're going to practice this tomorrow, so make sure you ask any questions if you have them. Thank you.